Okay, let's dive right into this. Think about it for a second. When you load up a website, stream a movie, or text a friend halfway across the world, where's that information actually coming from? Right? Most of us just naturally look up. We picture this invisible, ethereal web of data just beaming down from satellites floating around in space. But in this explainer, we're going to uncover the surprising truth about where the internet actually lives. And to do that, we have to go deep. Literally. We're talking about the invisible web and how physical deep-sea cables are the true power behind the entire global internet.
Yeah, we definitely love the idea of the cloud, don't we? We imagine this wireless magic handling our high-frequency stock trades, our video calls, all those cat videos just zipping through the air. But the reality? Oh, it's completely different. The cloud isn't in the sky at all. It is literally anchored under the ocean. The vast majority of our digital lives relies on a massive, heavy, very physical network of deep-sea cables.
And when I say the vast majority, I mean 99%. That is absolutely wild to think about. An astounding 99% of all international internet traffic travels underwater. That's basically everything. Satellites, they handle a tiny fraction of a percent. The real heavy lifting is happening right now in the freezing, pitch-black depths of our oceans. So yeah, your whole digital world is completely anchored to the seafloor.
Now, to handle 99% of the world's data, you're going to need a staggering amount of infrastructure. As we speak, there are over 750,000 miles of submarine fiber optic cables wrapping around our planet. To put that completely crazy number into perspective, 750,000 miles is enough cable to wrap around the Earth almost 30 times over. 30 times! It's this completely hidden physical backbone for our entire modern economy, just constantly firing data across the globe at mind-boggling speeds.
So, let's move into Section 1, Anatomy of a Light Pipe, Engineering the Deep. When you think of a traditional cable, you probably picture copper wires with electricity flowing through them, right? Well, scratch that. Modern deep-sea cables operate on a totally different level. They use fiber optics, so instead of electrical currents, these cables send data using incredibly rapid pulses of laser light. And because light travels so ridiculously fast, and these ultra-pure glass fibers have such massive bandwidth, just one modern cable can carry tens of terabits of data per second across thousands of miles. It's a total game changer. So how do you actually build something like that? Let's break it down from the inside out. Right at the very core, you've got the glass fibers. These are incredibly fragile, literally the width of a human hair. Surrounding those delicate little fibers is copper tubing. Now, this copper doesn't carry data, it conducts high-voltage electricity to power these underwater amplifiers called repeaters. They're spaced out along the route just to keep that light signal nice and strong over the long journey. Wrapped around the copper is a layer of thick, stranded steel wire. This is your heavy-duty armor. It keeps the cable from just snapping under its own immense weight. And finally, the whole shebang is wrapped in a tough polyethylene plastic shell to protect it from water, rocks, and everything else the ocean throws at it. And trust me, it needs that heavy-duty armor. Why? Well, think about this. The water pressure in the deep ocean is roughly equivalent to an elephant standing on your thumb. Ouch! I mean, think about how absurdly hostile that is. We are putting microscopic hair-thin glass at the bottom of the ocean, literally one of the most unforgiving environments on planet Earth. The crushing pressure down there absolutely demands that these delicate little data pipes wear a fortress of armor just to survive the trip. But here is the crazy paradox of the whole thing. Despite all those layers, the copper, the steel, the plastic, and despite the fact that it's carrying the entirety of the internet across the globe, the final cable is shockingly small. Usually, it's only about the thickness of a typical garden hose. Literally, you could wrap your hand right around the physical pipe that connects entire continents. Which brings us to Section 2, the massive drop, deploying the web. As you can guess, you can't exactly just toss a garden hose-sized internet cable off the back of a rented fishing boat. It takes highly specialized cable-laying ships carrying thousands of tons of carefully coiled cable inside their hulls. And here's the funny part. The data inside the cables is moving at the speed of light, right? But the actual deployment process? It is the exact opposite. These massive ships creep across the ocean at an agonizingly slow crawl of just about 1 mile an hour. It is incredibly slow, meticulous, and calculated. And the tactics have to shift depending on how deep the water is. In shallow shore water, the cable is super vulnerable to damage. So an underwater robotic plow physically carves a trench in the seabed to bury it safely out of harm's way. But as that ship moves out into the deep ocean, the strategy changes. They don't bury it out there. Instead, the cable is carefully draped over unmapped, jagged underwater mountain ranges and down into these vast, dark abysses. They have to painstakingly map the bottom using sonar to make sure the cable doesn't stretch across a deep gap and just snap under its own weight.
All right, on to Section 3, Danger in the Deep, Real Threats.
Even with all that crazy careful routing and mapping, there are roughly 100 cable faults every single year. Let that sink in. 100 times a year, a piece of the internet's backbone physically breaks. So, what exactly is severing these lifelines all the time?
Okay, if you spend any time online, you've probably seen those viral rumors claiming that sharks are constantly down there chewing on the internet. Well, let's just debunk that right now. Sharks are completely innocent here. The real enemies are way bigger, and frankly, mostly human. We're talking about commercial fishing nets dragging along the bottom, or massive cargo ships accidentally dropping their anchors right in the worst possible spots. And beyond human error, Mother Nature plays a huge role too. Underwater earthquakes and massive rock slides frequently shear these cables right in half.
Now, you're probably wondering, wait, if the internet breaks 100 times a year, why doesn't my Netflix buffer or my Zoom call drop every time a ship drops an anchor? Well, relax. Your stream is safe. The internet doesn't go down because the whole system is brilliantly designed with instant redundancy. If a cable off the coast of France snaps, your data is instantly automatically rerouted through other cables, maybe down through the Mediterranean or across a different transatlantic line. You won't notice a single thing. But for the engineers, a very stressful ticking clock just started.
Let's look at how these solve it in Section 4, Fixing the Broken Web, a Rescue Mission.
The process of repairing a deep-sea cable is honestly like a high-stakes rescue mission. First, a specialized repair ship has to race out to the exact GPS location of the fault. Then, they literally drop a massive grappling hook down thousands of feet into the pitch-black ocean, dragging it blindly along the bottom until they snag the broken ends and haul them all the way back up to the surface. Once they get that muddy, broken cable on board, highly skilled technicians sit down and painstakingly splice those hair-thin glass fibers back together, completely by hand, all while balancing on a ship rocking around in the middle of the ocean. Once it's perfectly spliced, they carefully lower the repaired line right back down into the abyss.
We spend so much time thinking of our digital world as this wireless thing, just floating effortlessly in the clouds, completely detached from physical reality. But as we've seen, our entire modern life relies incredibly heavily on the gritty, heavy-duty maritime industry. The future of technology is deeply anchored to the bottom of the sea. So as we keep building out AI, expanding virtual worlds, and demanding exponentially more data every single day, you kind of have to ask yourself, what happens when our digital hunger finally outgrows the ocean floor?